In retrospect, it is a difficult matter to find a red thread in our process, when the process itself has been dealing with methods so novel to us that we have been unable to anticipate what the output would be. If one would try to identify such a theme, then our suggestion would be the notion of vertical versus horizontal, and the tension between them in terms of stacking.
We disassembled the old Konsum building in Kiruna by detaching the individual vertical facades and then picking apart chunks of the more horizontal elements. The old central station was disassembled in a more volumetric manner, where spatial discontinuities were removed from the main rectangular volume.
These disassembled elements were then taxonomically ordered in a two-axis diagram, with the element's x position defined by its positional height relative to the building as a whole, and its y position defined by the orientation of its surfaces.
We then selected 27 different elements from the studio's combined efforts of an architectural element archive, and then used the aggregation engine WASP in Grasshopper to reassemble the parts in new constellations.
We defined the aggregation rules so that no part was allowed to connect to an identical part, and the connections defined were primarily lateral, which contributed to the elements staying upright.
With 238 iterations of random, rule-based aggregation, a total of 1,428 images were produced, of which 952 were used as input for the machine learning process.
From 2,757 genuine drawings made by the studio in axonometric and planar projection, 4 different machine learning models were trained. Around 685 images were used as a training input for each model, serving as base truth for a generator to learn how to generate similar images, and for a discriminator to learn how to approve only images generated sufficiently similar to the genuine ones. Like an architectural Rorschach inkblot test, the synthesized image created by the machine-learned model is sufficiently ambiguous to allow for different interpretations, as well as sufficiently similar, although in some cases barely, to the original images to be interpreted as architecture. In the latent space, where the results of the machine learning training take form, the interpolation between synthesized images makes obvious that from a finite amount of training images, an infinite amount of synthetic images can be created.
But what is the value of the infinite amount of synthetic images? Our approach to this question was comparable to that of flickering between the pages of a very thick illustrated encyclopedia. Perhaps a lot of the images might seem irrelevant, but the sheer fact of its encyclopedial massiveness makes probable that you will find something very interesting to you, if flickering about long enough.
With that approach, we found it only natural that when we encountered this image to the left, synthesized by the polychrome plan drawing model, intrigued as we were by its sense of different horizontal levels along a well-defined vertical axis, and its warm gradient of appealing colors, we designated it as our point of departure for further interpretations. The encyclopedial aspect of the machine-learned model also proved its value when the image in itself made us spontaneously think about an architectural reference, due to the perceived horizontal platforms extending beyond vertical elements by neural association made us think about Falling Water by Frank Lloyd Wright. Thus, our architectural statement was conceived, more so inspired by the architectural reference we chose than the synthetic image itself, but where the characteristics of the synthetic image was the primary reason the reference was chosen.
In terms of assembly, our architectural approach is guided by the principle of stacking. Stacking, as in ordering elements, in a way which produces different platforms or levels, accentuated by assembling horizontal and vertical elements so that they are distinct to each other.
In terms of tectonics, we aim to achieve a sort of interlocking stacking, where stacked concrete waffle structure cantilever platforms extend out from firmly attached joints with the vertical load-bearing pillars.
The previous processes of disassembly of Kiruna building elements, reassembly of said parts in novel aggregations, and post-assembly by use of machine learning to generate an infinite amount of synthetic similar images are all the three necessary for the encyclopedial outcome of the single synthetic image, which by mere perception made us think about the architectural reference of falling water, and so informed us about how to formulate an architectural approach to the further interpretations.
What guides us most is the interlocking stacking principle of the architectural reference, but all previous processes were necessary to produce such an insight. In our first attempt, in a physical translation of 1 to 200 of the whole image into a series of balconies extending at different heights from a stereotomic volume, the aim of the cantilever architecture guided by the falling water reference was not satisfactorily achieved, as the model turned into a very volumetric one, where the relationship between horizontal and vertical was not very distinct nor accentuated.
Thus, when zooming in on roughly half of the synthetic image in a physical translation of 1 to 50, we allowed ourselves to become increasingly inspired by the falling water reference. We wanted to emulate this distinctiveness of falling water's horizontal and vertical elements and experimented with an undulating geometry for the main vertical pillar, so as to make it more alluding to the organic shape of a cliff or boulder.
For the 1 to 10 physical translation, we focused on the area with the interlocking stacking joints between the load-bearing vertical pillar and the horizontal waffle-structured cantilevers.
Falling water has its vertical elements extruded from the rocky ground, perhaps not seamlessly, but nevertheless sufficiently blended into the cliff, while its horizontal cantilever elements are visually distinct. This is a quality we aim to extract, alongside the principle of interlocked stacking.
So for the fourth physical translation, in 1 to 200, we tried to reinterpret the whole synthetic image with the perspectives applied for the last couple of translations. With visually distinct horizontal platforms stacked, interlocked with, and extending from vertical load-bearing pillars, the result was, in relation to the approach of stacking, more satisfactory than our initial 1 to 200 model, which was overly volumetric. Here, horizontal elements stack along a vertical axis, which was our chosen approach.
Thank you for your time.